So, hey, I'm Dazza Greenwood from the MIT Media Lab, and here I am with
Amadeo. I'm a developer of a software tool called Symmetry, which we're going to be demoing really quickly right now to show a little bit how we can work with data and visualize it, basically.
And this is for the data visualization module in the upcoming computational law course. And so if you like what you see, you can sign up at law.MIT.edu. You want to show what your workflow is?
Absolutely.
Okay, let's take a look.
All right. So the main idea is...
So let's come right over your shoulder here and then tighten up on the screen. Prepare to be amazed.
All right, so the main idea is we want to bring in our data into the world. And so we do that by selecting our CSV data that we have. And when we do that, it comes in as something called a data set. So now our data set basically contains our data fields. In this case, our data has a field called $obligated and this claimant program code.
So this is just like some CSV data that Amadeo just grabbed off data.gov, downloaded some open public data from the government, showing some expenditures, and here's a couple of the columns, right? Yep,
exactly. And so then what we do is we want to build a data shape. So we create this new object called the data shape. And what that does is it ingests our data set that we imported, and then we can apply sorting and filtering and various transforms on that data to prep it for data visualization. Because basically we want to make sure this data that comes in all these different numbers, numerical ranges, and all this other stuff, we get it nicely massaged down to exactly the data we want, exactly the numerical ranges we want to be able to visualize it in this space.
The features of the data, and that we're showing the dimensions that will convey some meaning.
Yep,
so
exactly.
How do we do it?
And then finally, we create a data model where we bind these two things together. We take the data set and the data shape, we put them together, and it produces a process data set. So we have the same fields that we had in the original imported data set, except now they've been changed into a form that will let us then visualize them in an easier way.
So you have the data set, and you ingest it, and you choose a shape, which basically will let you kind of highlight the properties of the data and
sort it and normalize it, all these kind of things.
And then finally, a model for when it's time for the emitters and to express it in VR.
So the data model just has the data set, the data shape. It combines those two to produce another data set. And then finally, we can connect that with an emitter in the 3D space that will create an object for every element inside our data set.
Pretty cool.
And so that's what we did here. So this is already been created, but basically I created a data shape and I created an object that is going to represent our data points. In this case, a simple sphere. And then by configuring the emitter a little bit, we can then, on play, see it emit all of our objects. And so in this case, these are the large spheres represent objects with larger values in our data set. So these were higher $obligated values in the case of our column that called $obligated. And each one of these represents like a data point, which is I think a time inside our data set. It's like a date, like basically at these different points in time, there's different contracts, and they cost have a certain amount of cost associated with it, or dollars obligated to these, and then this is what we're visualizing here. So in a very simple way, we've just kind of, and I can restart this, we can just visualize this. But now since we're in a 3D environment, we can really start to play around with what's in this environment, or some aspects of these emitters to kind of change the artistic flavor. So for instance, these already have physics on them, so you can comically see that these large dollars obligated objects are actually usurping the smaller ones, or actually running over them, which is kind of funny in some sense. But by continually playing with this emitter, we can kind of achieve some interesting visual results. And then you can kind of see how by binding the different columns and those values to different properties in the 3D space, we can start to kind of manifest interesting visualizations. So let's just take this and maybe rotate this 90 degrees. This is the same shape basically, but now it happens on this, and now they're going to kind of fall from the sky. Maybe we can play around with some of these other properties like the radius of this, so they come out now a little bit. You can sprinkle all around us.
Almost like a literal cloud.
Yeah, exactly.
A value cloud here.
So with just a few little tricks, we can start to kind of get our data in, and now by adjusting parameters and values and taking the data source and binding it to this, we can kind of start to play around. So maybe instead of binding it to the shape of the object, the radius in this case, it's what we bound that field called $obligated. Maybe we want to connect it to the time of day, or a color value, or some other properties in the space. And so by doing these, we can just start to discover maybe what tends to convey some information in the data for a decision maker. Maybe there's some clever ways to make that happen that are as yet undiscovered, but you can kind of discover them by kind of playing a little bit.
Yeah, just so. So there you have it. Nice work, I have to say. Really rapid prototyping on your already awesome VR experience and almost artistic tool to be able to add it on these data-oriented and analytics-oriented ways to ingest data and to shape it,
Yep.
and then to connect that to a data model that can be expressed in VR. It's great thinking. And so our hope for the class is that, our intention for the class is that we'll start with we have the team of master students from Sloan that are interested in climate change data. We've got various people that are bringing different types of data or that we can connect with data sets, and we'll be doing some tests to see can we convey information that's as understandable or more understandable, or it makes it easier to explore in VR. And there's a lot of different things that we'll try testing, and I'm confident that we'll come up with like at least a handful of repeatable design patterns where we can use VR and actually get more out of our data. And actually, it's kind of fun too.
Yeah, the key is discovering this will be kind of being worked at in real time at the actual event. So if there are issues that come up, we can make changes on the fly. If inevitably there's some issue that that doesn't map very well or whatever, we can make changes right there. So
yeah, and what you mean partly is so people can use the symmetry tool. They can download it, and if there's issues, you could make some adjustments in the tool. So people that want to download symmetry to be able to learn the tool and use it to do our exercises and maybe join a team to do a project, visualize their data online, what kind of machine would they need in order to download it, and how much does it cost?
Yeah, sure. The type of machine is any kind of gamer-centric PC. So generally PCs that have discrete video cards, like NVIDIA cards or AMD video cards, and basically a decent modern computer PC that has those kind of discrete video card capabilities. And so they tend to fall more into the gamer world, but it's the same kind of underlying platform logic that powers video games, this platform. So that would be kind of the frame. And so the cost of these can range anywhere between $800 to $3,000 for the really top end computer.
And so, okay, great. And so, and where can people find out about Symmetry? It's you better spell it.
Yeah, symmetry.com. So SIMMETRI.com, and you can see the spelling there in the bottom left-hand corner.
Think. And it's worth it. And then again, to sign up for the course, this is what we call an IAP course. It's free, informal. I would very much call this an experimental course. Where we're trying several new things at once. So you can come and learn with us, hack with us online at law.MIT.edu, and we'll have some space for some people in person on ground, as they say, I just learned, at the Media Lab, but primarily this will be tuned for online participation. You can sign up at the website. And I think we may also allocate January 30th and or 31st so that people have time after. I'm sure we'll all learn a lot on Monday and Tuesday, the 23rd and 24th, and we'll have time to tweak things a bit, let teams work with and massage their data and come up with better presentations. And we'll probably do a capstone of some type at the end of January. And here's the best part. So when you're done working with the tools and coming up with presentations and demos, what we're going to try to do is show them as live streams through Google YouTube. And can you just you can say this better than I can.
Sure. So we could also stream 360 videos through Google's platform, YouTube Live. So we could actually create these live kind of data visualization environments, provided the students, if they come up with something that kind of works well in a live context, and that could be kind of neat too. And so we could also broadcast it out to anybody at home, what people are coming up with in the class itself.
Just so. So we'll schedule that at the end, but basically for those of you that take the class or those of you that are interested in learning about this but maybe aren't quite up for inventing it yourself or like hacking on a team and going to back to school to a class, so long as you have a VR headset, you can get them again for like $10 from Google, or talk to your son or daughter about using their Oculus Rift or something, or a gamer. Then at the end of the class, at the end of January, I'll just commit right now to doing some capper on January 30th or 31st. Just sit back, get some popcorn, put your visor on, and let the show begin and see what we've come up with globally. for free on Google, YouTube. All right, so thank you very much, Lynn, for being our on-the-fly camera person, and thank you, everybody. We'll see you online.